Welcome to a new lesson of the course. In this lesson we are going to program in assembly code to control the LED with the push button. This is the diagram of a GPIO pin configured as digital input. The value of the pin is stored to the register IDR. This is the schematic of the evaluation kit where you can see the push button B1. The lowest 16 bits of the register IDR have the state of the pins configured as digital input. The push button is connected to the pin PC13, so we are interested in the bit 13. When the push button is not pressed, there is a high level on the pin because of the resistor R30 and the bit 13 is 1. When the push button is pressed, there is a low level on the pin because it is connected to ground, so the bit 13 is 0. I am going to copy and paste the project P08 button B1 HAL to create the new project P09 button B1 ASM. As you already know how to do it, I am going to skip the process. I am going to create a file in the folder source for our assembly code. Inside RStudio I have to import the file. I am going to open it and paste the content that I have already prepared. This is the implementation I have made, a function called FB1LD2 that turns on the LED LD2 when the push button B1 is pressed. I am opening the file asm.s of the project P06 GPIO ASM2. To remind you of the assembly code I wrote to turn on the LED LD2, because I am going to reuse the symbols and some instructions. These are the symbols corresponding to the register BSRR that are to control the digital output pin PA5 where the LED LD2 is connected to. Two new symbols, GPIO-C IDR, that is the address of the register IDR of port C, where we can read the state of the digital inputs of port C, and GPIO IDR13, that is the mask that we will use to read the bit 13 of port C. It has all bit 0, but bit 13 that is 1. The name of the function is FB1LD2. We need to read the value of the register IDR of port C. We load its address to R0, and with the second LDR instruction, its value is loaded to R1. We load the mask with the bit 13 set to R2, and with the instruction AND-S, we do a bitwise AND with R1, storing the result to R1. This way we clear all bits but number 13, that will keep the value from the register IDR. This is the instruction AND-S that performs a bitwise AND of two registers, and store the result to the first register. The important point is that the flags N and Z are updated. In this case, we are interested in the flag Z, that indicates that the operation has produced a result that is 0. Now we use the instruction BNE, branch if not equal. Let's recall how it works. The instruction BNE performs the branch to the new address if the two compare values are not equal. If previously we have executed the instruction compare, CMP, or like now, the flag Z is 0. BNE evaluates the value of the flag Z. With the instruction AND-S, we do a bitwise AND to know the value of bit 13, because the other bits are clear with the mask. If bit 13 is 1, push button not pressed, the flag set is 0, and we jump to the label FB1LD2 off, where we turn off the LED LD2. If VNE doesn't jump, we go to the label FB1LD2 on, where we load the symbol GPIO BSRR BS5, that we will use to activate the digital output for LED LD2, as we did in a previous lesson. With the instruction B branch, we jump to the label FB1LD2N, where we load the value to the register BSRR of LD2. If VNE jumps, we go to the label FB1LD2 off, where we load the symbol GPIO BSRR BR5 that we will use to deactivate the digital output for LED LD2, as we did in a previous lesson. On the label FB1LD2N, we load the symbol GPIOA BSRR, that is the address of the register BSRR for port A. With the instruction str, we load the value of register R1 to the value stored in R0, that is the address of the register BSRR. If the program passed through FB1LD2 on, the value of R1 is the symbol GPIO BSRR BS5, and the LED will turn on. If the program passed through FB1LD2 off, the value of R1 is GPIO BSRR BR5, and the LED will turn off. Finally, with the instruction BXLR, we exit from the function and we go back to the main program. Let's copy the prototype of the function to be able to use it in the file main.c. Replace the content of the infinite loop with the call to the new function. Let's debug the program to see how it works. I am setting a breakpoint on the call to the function FB1LD2. The program will stop at the breakpoint. Let's enter the function with the step into barum. Let's move the general register window close to our code to see the execution better. I prefer the hexadecimal number format. Let's go for the first time through the function with the push button unpressed. The result of the AND instruction is in the register R1 and it's not 0 because the push button is not pressed and the bit 13 is 1. The program runs through the label FB1LD2 off to load the symbol GPIO BSRR BR5 that will turn off the digital output. Let's execute the function step by step again. This second time I have the push button pressed and you will see that the result of the AND instruction is 0 and the program will run through the label FB1LD2 on. That will make that at the end of the function the LED will turn on with the instruction strR1R0. I hope you have enjoyed this lesson. That's all for now.